Good day, everyone. I am Engineer Gerson Gonsalvo. Today, I'll be presenting a review of the paper Application of Fuzzy Logic Review by Komal B. Aflenchwar and Rufali S. Kokate, published in the International Research Journal of the Engineering and Technology in April 2020. The review focuses on understanding fuzzy logic, its core principles, its application in different fields, and the research gaps identified by the authors. So, fuzzy logic is a computational approach that allows reasoning with uncertainty, similar to human decision making. Unlike classical logic that is binary, true or false, fuzzy logic operates with degrees of truths ranging from 0 to 1. This makes it ideal for real-world system where information is often incomplete, vague, or imprecise. The, the author, both from engineering and electronics backgrounds, emphasize the role of fuzzy logic in control systems, automations, and intelligent decision-making. Their goal was to summarize various applications of fuzzy logic across multiple domains and explain its underlying mechanism. Let's begin with the objectives of the paper. The authors set out three main objectives. The first one is to explain the basic concepts and working of fuzzy logic and the fuzzy inference systems. The second one is to identify and summarize the wide-ranging application of fuzzy logic in engineering, science, and everyday technology. And lastly, to highlight how fuzzy logic addresses uncertainty and supports intelligent systems design. In essence, they wanted to show that fuzzy logic serves as a bridge between human reasoning and computational precision. Um, Next is the research question. The review sought to answer three main questions. How does fuzzy logic address uncertainty and approximate reasoning? The second one is which fields or systems benefit most from the application of fuzzy logic? And lastly, what are the key components and stages of the fuzzy inference process? These questions guided the structure of the review, focusing on how fuzzy logic is applied and where it demonstrates the most value. Moving on to the methodology, since this is a review paper, the author did not collect new data through experiments. Instead, they conducted a literature review of existing research papers, journals, and case studies involving fuzzy logic application. The gathered data was organized into categories like chemical science, healthcare, agriculture, traffic systems, environmental science, and household automation. They also included some industrial and petroleum sector examples. The author explains that a typical fuzzy inference system has three main stages. The first one is fuzzification, where crisp numerical inputs are converted into fuzzy linguistic terms like low, medium, or high. Inference, where a set of if-then rules are applied to determine possible outcomes. The falsification, where the fuzzy output are converted back into precise, actionable values. These processes make fuzzy logic adaptable to systems that rely on human-like reasoning. Next, let's move on to the findings, the heart of the review. The author presented several examples showing how fuzzy logic has been successfully implemented in different areas. For example, chemical science. It uses in controlling pH levels and regulating pipeline flow, where exact mathematical modeling is difficult. Fuzzy controllers improve system stability and safety. The next one is healthcare. It applied in decision support system for medical diagnosis and drug using, and drug dosage control where symptoms and data may be uncertain or imprecise. The next one is agriculture, utilized in pest management, crop selection, and irrigation control using fuzzy expert systems that account for varying weather and soil condition, and many more. In each domain, the strength of fuzzy logic lies in its ability to interpret vague or approximate inputs and produce reliable real-world decisions. Despite its usefulness, the author also identified some gaps and limitations in the review studies. First, the paper is descriptive. It summarizes existing works but doesn't include new experiments or quantitative analysis. Second, it lacks comparative evaluation of fuzzy logic against other intelligent systems such as neural network or machine learning models. Third one is scalability and implementation challenges in large-scale systems are not deeply addressed. And lastly, while hybrid fuzzy models are briefly mentioned, their potential integration with AI remains underexplored. These gaps point to opportunities for future research, particularly in combining fuzzy logic with modern AI techniques to enhance system adaptability and performance. In conclusion, fuzzy logic remains a powerful tool for solving problems involving uncertainty and linguistic reasoning. It extends classical logic to handle partial truth, making it valuable for control system, diagnostic, and intelligent decision making. The author concludes that fuzzy logic's main strength is its versatility. It can be customized and integrated into virtually any systems that requires human-like interpretation of data. However, for fuzzy logic to stay relevant in the age of artificial intelligence, researchers must focus on hybrid models, empirical validation, and real-world testing. So, to summarize, fuzzy logic bridges the gap between human reasoning and computational modeling. It is applied successfully in many fields, including chemical processing, healthcare, agriculture, environmental monitoring, and automation. Its flexibility in handling uncertainty make it deal more complex or for complex and adaptive systems. For future works, it should be integrate fuzzy logic with AI and machine learning to improve accuracy and adaptability. Um, so thank you for listening. That concludes my presentation on application of fuzzy logic, a review.